Epperson. I'm the CEO of Vigilant Aerospace, and I'm going to be talking about new models for providing airspace management as a service. In particular, we're going to be talking about systems that can help emerging programs, small and medium-sized programs, which sometimes don't get as much attention and as much resources. And we're going to talk about how, in the first half of this presentation, I'm going to talk about our product, Flight Horizon, our history and background in developing that and working very closely with NASA. And in the second half of my presentation, I'll talk about how we are taking Flight Horizon Commander, one of our products, and using that as a software as a service and Airspace Manager as a service to help enable programs quickly and get them the types of systems and risk mitigation and other things that they need to be able to launch. We'll start out talking about the company a little bit and about the products, and then we'll talk about those program challenges. So we're a tech startup. We have experienced technology leadership, and we have some venture capital firms involved in backing the company. We have offices in Oklahoma City and in Fargo. We've got Ryan Ashheim here, who is in our Fargo office. We provide airspace management and detect and avoid systems. We've licensed from NASA patent prototype software and the algorithms to make that work. It includes the hardware integration. It's exclusively a software solution, so we are agnostic as to data and sensors. We have pre-integrations built for a lot of popular sensors, and as new things come out, as I'll talk about quite a bit, we add those to the tool set very quickly. Provides active situational awareness, and I'll show you a quick video here in a few moments and some pictures so you can see what I'm talking about with that. Provides active detect and avoid either for a pilot to provide an advisory and a specific command to get out of a situation and maintain well clear, or to an autopilot. And that's really what NASA designed the system for. That's where we're heading, and we'll talk a little bit more about that. It uses both existing infrastructure and is designed to be flexible and use future infrastructure, and it helps meet FAA requirements. So the basics of the product are that the software sits in the middle. On the left-hand side here, you've got your own ship, and you'll be tracking where that is, and then you'll be tracking information from other aircraft, both from transponder receipt, from a radar, from other sources of online data, including eventually, hopefully, UTM and network sources. And then the software uses that to present you with a picture, present you with important alerts, warnings when necessary, and then self-separation advisories when necessary. The data flows from your sensors, your radar, your transponders, the network if that's available, into your airspace model and avoidance model, which is continuously running and monitoring the airspace. And then that information is digested and sent out as needed to the Airspace Manager and that user interface out to a pilot or out to an autopilot. So just a little bit about the way that the software is thinking in the background. It starts out detecting, parsing the data that it's got, fusing that together, looking at it, and creating a picture of the airspace that includes an index of all of the targets. It's then tracking those targets, building trajectories over time, predicting where the aircraft are going to be, and then predicting potential collisions. And it's doing all of that many times a second. Usually the latency of the sensors and other inputs is much higher than the latency of the software. The software can do this pretty much with as much data as you can get it with the modern infrastructure. It then iterates through strategies, determines if there is a self-separation strategy, determines the most efficient of those, and then based on some parameters that you might have about your particular airspace or the types of maneuvers that you need to make, and certainly including the performance of your aircraft, which you set up and save in the system when you first set it up, it will then provide that avoidance strategy for you. And then it will continuously monitor on a sub-second basis that the aircraft have not gotten back into a conflict situation or that a new conflict has not emerged, and then it will find a new strategy to get you out of that situation. So that's really, NASA spent a lot of time on this. We've picked it up and have developed the software and commercialized that fundamental process. So from our point of view, there is a lot of effort right now on detection. That's really important. Obviously, there's a lot of great systems for navigating aircraft, but there is this big gap that's going to have to be filled in the industry in order for us to have truly autonomous systems in the future, and that's the ability to do fully autonomous avoidance. And that's really where this technology ultimately comes in, although there are several steps between here and where people will be using it. So when you do use the user interface, this is the 3D synthetic cockpit view version of that interface, and we're constantly advancing this. There's new versions of this just since I made these slides. Your own ship will sit in the middle of that, so it keeps you aware of where you're located. You'll be tracking other aircraft, and it'll show you those. Even if you cannot see them otherwise, it's going to be tracking those aircraft. even if they're out beyond visual line of sight or if they're behind a hill, it's going to be tracking those usually by the transponder, and then of course as they get closer, they also use radar, particularly if they're not participating in air traffic control. It'll then predict if you have potential conflicts, it'll figure out where that is, it'll tell you about it, and then it will begin producing those advisories. So a little bit of background real quickly about this. 2013, NASA started developing the system, started doing some basic testing on it. 2015, late 2015, we licensed this technology. We started doing beyond visual line of sight testing with NASA, and I'll go over that a little bit more in 2016. 2017, we really launched our commercialization process, and we actually were called out to help with some disaster response flights, and we were able to pull the system in, have it set up very shortly to be able to help with some of that. And then in 2018, we have multiple flight campaigns going on. We're involved in new programs, and we're about to launch Flight Horizon 2.0, which we're very excited about. And that's really the second half of my discussion here. 2018 and 2019, we're going to be involved in IPP flights. We're involved in a couple of teams there, and we're going to be learning a lot from that. Very excited about that. And then we'll have a new version of the software as UTM and other things mature and begin to be available for our system. So this system is designed to fly and has been flown with small, medium, and large. It's highly parameterized in the sense that we can change it really on the fly, make the settings that we need within certain boundaries to fly with different types of aircraft. Here's a quick video of the system in use. You'll see here, white aircraft in the middle is ownship. It's flying through a scenario in which it's got some conflicts that have been detected. You can see that green line, that's the computer thinking about and providing a specific resolution advisory, specific advisory there to get out of that situation, and then releasing the autopilot back to the flight it was originally on. That green line so it provides audible warnings, it provides visual warnings, it provides text, and all of that can also be sent out to other systems, including, of course, the autopilot. So it's a proven beyond visual line of sight performer. This is something that NASA designed it for initially, has tested it, and published an AIAA paper with NASA about this. We had FAA and FCC observers come out and work with us at NASA Armstrong while we were going through this process. It's a proven detect and avoid performer. It's been through hundreds of encounters now in which all different types of scenarios have been tested with real aircraft, both manned and unmanned scenarios, and we've also co-authored a paper with NASA about that. We had an opportunity last year to go out and sponsor and support a team called humanitarian-drones.com. They were providing disaster response flights to FEMA to help do emergency damage assessment after Hurricane Harvey in Houston. They were able to get 5 ECOAs under the blanket TFR in the region and go out and do those flights during that emergency. So that was a very educational, very useful process. Recently, we have been called back in, and the system has been subscribed to by NASA for multiple programs. Sonic Bat 2017, UNIMAX in 2018, and in 2018-2019, NASA is using it for, they actually have 3 subscriptions for 3 different air management systems for their commercial supersonic programs. So it's for formation flying in some cases within UNIMAX, and in other cases it's for extensive logging and data collection from multiple sites. And then finally, we're involved in a couple of the IPP teams. We are on the North Dakota team, which we're very excited about, and that's developing quickly, and we've already heard exciting stuff about that this week. And then we're also on the Alaska team, so we're going to get a lot of additional flight experience that way. I'm happy to provide information on the background of the technology if you're interested in that. Most of this is on our website, so you can get access to it. All right, so we have 3 products. We're talking about the GCS, which is for an individual aircraft. It's really for an individual pilot. There is the Commando version, which is for air traffic management, really for airspace management for multiple unmanned aircraft. NASA uses it for all kinds of things, but we're primarily focused on enabling small programs to get out there and mitigate their risks and be able to make their safety case. And then, of course, there's the pilot version, which goes on board and is intended to talk directly to an autopilot. That's where we feel the industry is going and is going to quickly be in need. So I won't go through all the features of Commander, but we're going to talk a little bit about Commander now. It does provide that 2D and 3D visualization process. It fuses data from multiple sensors. You can use it offline, completely over the air if you're using ADS-B and either a ground-based or even an onboard radar. So all of that can be fused together. But if you have online access, and particularly if you're in a spot where UTM is being tested or eventually deployed, then we will also very much pull that data into the system. It provides a lot of logging, and that's really useful for early stage programs where it is important to be able to do visual line of sight flying, prove that your system works over and over, and just be able to have that, replay those logs instantly, document that, and that's all built in. When you start using our system, it does that out of the box. So real basic diagram of how it works. You've usually got transponders, rules of the road, that's number one. You use that, obviously, to avoid larger aircraft and make sure you've got that in your system. Radar is second. Usually that starts as ground-based radar, and quickly there are emerging onboard radars in larger aircraft. They have access to an onboard radar, so we already have modules to pull that data in and begin to fuse it with the Airspace model. And then visual sensors, some of those are emerging. We're very excited about those. They offer a low-cost alternative to detect a lot of different types of aircraft. And then there are future sensors. There are acoustic sensors, other types of visual and infrared sensors that are emerging. And those are great add-ons for our system. So that's really how it's designed and architected. Then that data goes through and then is pushed out to a display, to an autopilot, to a translator where it can actually be displayed in other systems. So we can output that. So if you already have existing systems into which you want to put this information, particularly the resolution advisories, we can go ahead and push that. So it's sold as software as a service. It's a package. It includes all of the updates and upgrades that you need over time, and it includes that integration to the hardware. So I'm going to talk a little bit now about how this approach to airspace management, where you have a piece of software that is architected correctly, can help particularly small and medium-sized organizations where there's a lot of complexity that you have to overcome with some solutions. Having a system like this can help overcome a lot of that quickly. So first of all, obviously, programs come in all shapes and sizes. They usually start out small, and that's something that our system is designed to support. It's designed to support that by allowing you to deploy only what you need to deploy initially, to only talk to the systems that you need to talk to. And we have trial versions that you can use for initial testing, to do visual line of sight testing, to set up your system, test your environment, and to begin to do integration. And so we're finding a lot of interest in that. That's where we're starting with a lot of people, is to be able to do that initial integration, maybe with assets that they already have. The other thing that we find with programs, really medium-sized programs, is that they have their particular goals, all types of goals across the industry. So you've got public sector, private sector, mixed public and private partnerships that are developing programs, that are supporting industry, supporting getting out there with different types of flights. And what we don't want is we don't want the airspace management system and the safety management and the safety case to drive what the program can do. So we really want the system to be able to support the program's goals and not the program have to essentially adapt to what the system will do for you. So our system is very flexible, and it's intended to come in small, and you can add what you need as you need it and as you grow. Additionally, of course, regulation, becoming compliant, getting the waivers that you need, and being waiver ready across multiple uses and growing uses over time for your program is extremely important. This is something that we spend a lot of time focused on. We're on some of the industry standard setting committees, including the ASTM committee on UAS standards, for detect and avoid testing. And so we're constantly thinking about this. A lot of what we're seeing is a trend towards standards that ask for a fused system that is detecting both cooperative and non-cooperative, and that is creating an overall picture that presents you and your systems, your airspace management system, and eventually your autonomous avoidance system, with a picture of the airspace that is over-detecting, that's detecting all the potential targets, hopefully more than once, and fusing them into the system. So obviously you may have some non-cooperatives where you're only detecting once, your radar is hitting them, and lots of cooperatives where your radar, your transponder, receiver, and other things may be all fusing those together. But the idea is that you're getting very, very high coverage. And so that's a really important part of making the safety case, and that's really where we're focused with the whole system that we provide. And obviously moving towards UTM in the future as a way to help with that whole process is important. The other thing that we find related to regulations and waivers, of course, is that small and medium-sized programs and even large programs, there's a lot of moving parts, there are a lot of systems and technologies that have to be implemented. And our goal with this product, Flight Horizon Commander, is to do as much of that work ahead of time, out of the box, so that you have the hardware integration, you've got recommended hardware compatibility, things that you can pick up off the shelf, plug in, and the software is going to already be prepared for that. So the burden of integration is not on you or your program. The burden of a lot of the risk management, the risk mitigation, and the argument that you need to make about how you're flying safely and what that means for you is included in the product. And So we're trying to do as much of that thinking and anticipate, hopefully years or more ahead, where the regulations are going, where the systems are going, including especially UTM, so that our system is aware of all that out of the box. So cost and complexity, this is a big topic. It's a topic that I'm sure everybody here thinks about a lot. You've got staffing and staffing requirements. You probably don't have a full-time airspace manager. In a lot of smaller programs, we run into that a lot. And you've got training, you've got retraining requirements. You've got total cost of ownership of having a program like this. And so we think about that up front. It's one of the reasons that we price our system as an annual subscription where you get all of our updates. So as things emerge and new hardware becomes popular, it's going to be included in your subscription. And the interface is relatively simple. The system is doing a lot of its work in the background. And so the point is that the training can be kept to a minimum, and you can have people who can get trained and use this system because it is relatively non-complex compared to some other ways you might try and fulfill these needs. And then finally, capital investment risk. Say that these programs cost money, and we're very aware of that, we think about that. And you want that capital investment to be very justifiable and very future-proof. So you want to have made this investment in such a way that you know you can expand it later, and that as regulations change and new technologies emerge, you are in a position to use the existing system, the existing commitment that you've made, and expand it outwards to be able to cover the things that you need to cover, both regulations and new sensors, for example. So we're very focused on modularity, very focused on scalability, extensibility. Something you may have seen in my prior diagram is you can put these systems side by side and they will talk to each other. You can put an individual ground control station system that an individual pilot is using, and they can communicate back. And the Aerospace Management commander system can subscribe to that GCS unit. It can subscribe to an edge unit, a pilot unit that may be flying at the edge of your airspace. That data can all be pulled back and aggregated into your overall airspace model. It might be an important part of your strategy to be able to watch around the edges and fly around the edges of your airspace and have all of that centralized and logged in your system. So all of those things help to make the system very scalable and very extensible. Architecture really matters, and this is one of our watchwords really in the office and in our software development process. How your software is architected from the beginning, the thought that's been put into it is going to have a big impact on your ability to continue to use that system and for that system to be able to respond to your needs in the future. So that architecture is what we think about a lot. We are to show you some additional videos, provide additional information. We'll be happy to talk with you if you have questions about this system. But thank you all very much.